Yo, this is Coach Ray here. Somehow I'm going to manage to teach you factor by grouping today, despite the fact that I was in a car accident this morning. But I survived. We need to learn how to factor by grouping. So here we go. Alright, let's go. First thing you need to know about factoring by grouping, and this is important enough to write down, is factoring by grouping always requires 4 terms. Okay, I'm going to say it again slowly so that I'm really emphasizing it. Factoring by grouping requires 4 terms. So if you look at example 1, you look at example 2, good. 1, 2, 3, 4, 1, 2, 3, 4, 4 terms in each. I'll discuss example 3 and example 4 when we get there. All right. So factoring by grouping goes like this. I am going to take my first 2 terms and group them using parentheses. Hence the name factoring by grouping. I'm going to take my back 2 terms and group them using parentheses. Okay, and I included that plus in with the 15y just to show that that's just positive 15y. If it were a negative number, it would be a minus right there. Same thing. All right, once I group, I'm just doing greatest common factor in each group. So I'm just looking at my first group here, my 5y cubed plus 3y squared, and I'm going to do greatest common factor. I cannot factor out a number here because I have a 5 and a 3. They don't have anything in common. Okay, but I do look, I got 3 y's here, I got 2 y's here, so I can factor out 2 y's. That's the most I can do because this one only has 2 y's. So I'm going to factor out y squared. And then I got to write what I have left. Okay, I took 2 y's out of this first term, so I still have a 5 there, and I still have 1 y left there, because there was 3 originally. Second one, my 3 is still there, but I took both y squareds, so that's all that's left there. Okay, now I'm going to greatest common factor the second one. Second group, I can factor out a positive 3. Okay, because 3 can go into both of those. I can't factor out a y, though, because they both don't have a y. So I'm ready to write what I have left. When I take a 3 out of there, that would be 3 times 5 would give me 15, and my y is still there. And when I factor out this, I still got plus 3. It is at this point when you are factoring by grouping, it is very important that you check and make sure that these 2 binomials are the same. Your 5y plus 3 and your 5y plus 3 are the same. If they're not, you messed up. If they're the same, you're doing good so far. Okay, so really important that we always check for that. Okay, there's only one step left. Okay, the last step is very easy, but it's confusing to explain. I still am going to explain it because I want you to understand why we are doing this step, but you're probably going to forget the explanation anyway, but the step is really easy regardless. Okay, so here is what I'm looking at. This is all one big term. This y squared parentheses 5y plus 3, that's one giant term. Okay, plus separates terms, so I got plus in the middle. And I got another giant ugly term, 3 parentheses 5y plus 3. That's a second giant ugly term. Both of these terms have something in common, yes? Okay, both of them have a 5y plus 3 in common, so I can use greatest common factor and factor out what they both have in common. Okay, so I'm kind of doing greatest common factor again. So if they both have a 5y plus 3 in common, I'm going to write my 5y plus 3 out front, and I'm going to write what's left. And because it's a binomial, I'm going to put it in parentheses, which is fine. But now I need to write what's left. So if I take a 5y plus 3 out of this first term, what is left is y squared. If I take a 5y plus 3 out of this second term, what is left is a plus 3. I have now officially factored example 1. Okay, now, the explanation was confusing where I'm factoring out a whole 5y plus 3. We don't usually factor out that much. Okay, but really just look at what I did. My binomial that's written twice, I write it down here, and then whatever's left, my y squared plus 3 is written in the other one. All right, example 2. Before I start example 2, I want you guys to notice something. My first term is AB. Second term is 3CD. Not really much in common with AB. In fact, nothing in common with AB. So I'm nervous about grouping those together and then doing greatest common factor. But check this out. I got a 4a squared b over here, and then I got a c to d in the back. Okay? Most of the time you do not have to do this step, but I specifically looked for a problem where you have to do this. So this is rare. But if I tried to start the problem as it is right now, I would not be able to do greatest common factor and pull stuff out. Okay? But if I switch these two, now I'll have A's and B's up front, I'll have C's and D's in the back. I'm clearly going to have some stuff I can greatest common factor out. 99.9% of the time, you can greatest common factor right how it is from the beginning. Just I wanted you to see that there is a possibility you might have to switch a couple terms around. Okay? Commutative property says you can move stuff if it's addition. So 4 plus 7 is the same thing as 7 plus 4. That's why I'm allowed to do this. All right, so let me rewrite my problem here. I've got AB plus 4A squared B plus 3CD plus 12ACD. All right, next step. Group my front two. Group my back two. Greatest common factor in the front. I see that they both have an A. They both have a B. So I can take both of those out. Okay, write what I have left. I took that whole AB out of the front, but remember this is the opposite of distributive property. So AB times 1 would give me that AB. It's not 0, even though I pulled it out. There's still a 1 there because we're talking multiplication. If I take an AB out of this back part, I still have a positive 4. One of those A's is gone, but one of them stayed, and the B is gone. Okay, greatest common factor out of the back. I think I could factor out a positive 3. They both have a C, they both have a D, so I can take both of those out. Okay, right, what I have left, I took the whole 3CD out, so I'm left with a 1. To get this, I have a positive 4. I took the C and the D out, but the A stayed. Pause here, double check. Is my binomial the same? Yes. That means I haven't messed up yet. That's a beautiful thing. I'm ready to keep moving. Last step, I'm going to just write my answer here. I got this 1 plus 4A, and then what I have left is AB plus 3CD. Beautiful. Okay, I'm going to keep moving, and I'll take questions at the end if we have them. Example 3 and example 4 are different. Okay, first thing I noticed, neither of them has 4 terms. So factoring by grouping, there's already a problem because there's only 3 terms and not 4. And I need to group the front 2 and group the back 2 in order to factor by grouping. So I already have an issue. I'm also going to tell you this. When I look at example 3, I see a quadratic. Okay, ax squared plus bx plus c. What I would do is this. I put my 2x squared here. I put my negative 12 here. This is probably 2x times x. I'm going to guess 4 and 3. So the area of this room is 3x. The area of this room is 8x. I'm trying to make a negative 5x. So boom, make that negative. Okay, and my answer is this. When I see example 3, that's what my brain goes to. I'm very good at that. Okay, my brain loves that. I can visualize it. I'm good at picking the numbers. I do that very quickly. So I would not factor example 3 by grouping. Okay, but I'm going to tell you this. Not all brains work like my brains. Some of you hate this area model and factoring this way. The only reason I am teaching you grouping right now is the people that hate this area model usually love factoring by grouping. If any of you come to me and say, I can't factor quadratics, I'm not going to teach you area model again. Instead, I'm going to have you factor by grouping. Okay? It's usually like a 50-50 split. So I just wanted to show you both so that you can decide what's best for you. Okay, but we are still going to get that same answer. All right, so let me get rid of that. All right, and let's go to factoring by grouping. So I have to fix this issue of I've only got 3 terms and I need 4. What I'm going to do is I'm going to take my negative 5x in the middle and I'm going to split it up into 2 terms. That way I'm going to have 4 terms. Okay? But I have to split it up a certain type of way. Okay? And it takes 2 steps to figure out how you're going to split up that middle term. And I don't like these 2 steps. That's usually why I don't factor by grouping, but whatever. Okay? That number is A, this number is B, this number is C, and the first step is multiplying A times C. Okay? So I'm doing 2 times A times C is 2 times negative 12, which is negative 24. Okay, remember, what I'm doing right now is I'm doing some math in order to figure out how am I going to split up my middle term. All right, the other thing I need to do is I need to find 2 numbers that multiply to give me negative 24, and when I add them, I get negative 5, the B term. If I did negative 8 times 3. That gives me negative 24. And if I added negative 8 plus 3, I get negative 5. That's how I need to split up my middle term. So I'm going to rewrite the problem. 2x squared minus 8x, that came from that negative 8, plus 3x, that came from that 3, and then I got minus 12 in the back. So what I did is I took negative 5x and I split it up to negative 8x and plus 3x. Same thing. Negative 8x plus 3x is negative 5x, so I didn't change the problem. I just now split it up in a way where now I got 4 terms instead of 3. Okay? All right, time to factor by grouping. Group my front 2. Group my back 2. We're going to do greatest common factor. So this front one, I can take out a 2 out of both. Both of them have an x. Okay, right, what I have left, I took out the 2. I took out one of the x's, so one x is left. Back here, I got minus 4 because my x is gone. Back one, I think I can factor out a positive 3. And that's it. Okay, if I take the 3 out, I'm left with an x. And here I'll be left with negative 4. So I pause. My two binomials are the same. I want to celebrate. Yay, I'm happy. I'm doing good so far. And now I'm ready to write my final answer is just x minus 4 and 2x plus 3. Okay, same answer I got using area model. But about 50% of people usually like area model, 50% of people like factoring by grouping.
So if you know one way, you recommend the other way?
Valeria just asked if we like one way, do we have to use the other way? The answer is no. When it comes to factoring quadratics, you do it however you want. Okay. On a test, though, I will give you problems like example 1, example 2, where there's 4 terms. On those, you have to use factor by grouping. On quadratics, you have your choice. Okay. All right, example 4. I'm going to do one more of these. I'm going to try to go quickly. I'm going to start by multiplying a times c. So 6 times negative 3 is negative 18. I need two numbers that multiply to give me negative 18 that add to give me 7. I'm thinking positive 9 and negative 2. I'm going to rewrite my problem. 6x squared plus 9x minus 2x minus 3. So 9x and negative 2x still makes my positive 7x, but now I got 4 terms. I'm going to group, factor out. If I take 3x out, I think I have 2 and 1x left here. Back here I took the x and I'm left with a 3. Back here, this one gets interesting. I got negative 2x and negative 3. If I'm strictly looking at the 2, the x, and the 3, nothing in common. Numbers don't have anything in common. There's not an x in both. Do you see what we still could factor out, though? And we have to factor something out, because if we brought it down exactly how it is, my binomials are not going to be the same. I could factor out a negative 1. Okay, if I factor out a negative 1 and write what I have left, opposite of distributive property, negative 1 times 2x would give me that negative 2x. Negative 1 times positive 3 would give me that negative 3. So essentially what it did is just change both signs, which is awesome, because now my two binomials are the same. 2x plus 3 is the same in both. Okay, let's write my answer. I got my 2x plus 3. What's left over? I got my 3x minus 1, and I'm done. And that is how you factor by grouping.